Hello, my name is Adam, and welcome to this Immerse video series supported by IES. In this video, we're going to do a quick latent class analysis from start to finish in MplusAutomation. As a quick disclaimer, the purpose of this video is to demonstrate the efficiency of the MplusAutomation method, but in a real research context, a latent class analysis should be investigated carefully and slowly. Class diagnostics need to be investigated. Estimation errors need to be looked for, and many other things. So we are going to use what I call a tidy MplusAutomation approach, which is designed to increase replicability. So here are the steps that we're going to go through today in this tutorial. First, we are going to download scripts and data from a GitHub repository. Then you're going to introduce the data example and LCA indicator variables. Next, load packages, read data into R, and then we are going to begin estimating models in the enumeration process. And we will create a model fit table, which is close to publication ready, plot information criteria, compare conditional item probability plots, and finally create a publication ready conditional item probability plot. So I highly recommend following along, and you can do this by clicking the link and downloading all the scripts and data you'd need to replicate this analysis. By following along and typing the code, you'll get a good practice. So this is the data set we're going to use for an example, and you can find more information about this civil rights data collection data that we use for this analysis here. Now we're going to use 6 latent class indicator variables in our model. The first 3 variables are students reported serious incidents of being harassed or bullied based on disability, race, and sex. And then the next 3 indicators are the number of school staff employees on campus who are counselors, psychologists, or law enforcement officers, whether or not these schools have these staff. So now I'm going to switch over to my RStudio window. As you can see in the top right corner, I'm working in an RStudio project. And importantly, we have these 3 subfolders in the bottom right-hand corner, a data folder, a figures folder for figures to save our figures, and an MplusLCA folder for where we're going to put our Mplus models. So here, I'm going to run this code chunk in our Markdown and load the packages. We have the MplusAutomation package, and then other packages from the tidyverse, as well as some packages for making tables and plotting. So now we're going to read in the CSV data file from our data subfolder. So we can see here, there's the data subfolder, and this is the name of the file. So we need to, using the read CSV function, we're going to call this data object bully data. And so we need to specify the subfolder data. And then we're going to type in the name here. CRDC LCA data. So we can run that, and now we can see our data object in the R environment, and there are 22,027 rows or observations in this sample. So I can click here and we can see our 6 dichotomous indicators. 0 indicates no reported harassment in this school. Each row is a school, and a 0 for the staff indicators indicate that that school does not have a counselor, psychologist, or law enforcement officer on their staff. These first 2 columns we can ignore, they're just ID variables. So now we're going to do enumeration, which is creating a series of models and that we can then compare using a summary table. So we can see here that this inside part of the code is going to run a single model, and then surrounding this we have a looping function which is going to loop or iterate across and specify 6 models, and wherever we see k, we're going to insert the number of the model. So in the title, in this classes argument, we're going to insert 1 through 6, and here in to create the model names, input and output files, we're going to input the numbers 1 through 6. So the functions which estimate these M+ models using MplusAutomation are the MplusObject function for creating the input syntax, and then the MplusModeler function, which is going to produce the DAT file and generate the input and output files and run the models. So in block and caps, these arguments are MplusAutomation arguments, and in the parentheses in green, this is M+ syntax. So starting here, we're going to need the variable names for this analysis, and I can find these here just by typing names, bully data, and I'm going to copy these names into the categorical statement. So now we need to copy this list of names into the useVar statement, as well as in this plot argument for which shows the order of that the items will be shown in M+ plots. The next step is here we need to specify the name of our data, which we know is bully data, here and here twice. So we would write that name in the use variable statement and the our data statement. And now here in the MplusModeler, we need to give as the first argument the name of our MplusObject that includes the input syntax, and then we need to specify where we want these models to be generated, and that's going to be in this MplusLCA folder. So I'm going to just type MplusLCA and call this just LCA dot, and copy this here as well in the MplusOutput input and output folder files, and just call this LCA. So now we're ready to run this, and we can look in our MplusLCA folder and then run these models. You can see here in the bottom, it's running each model pretty quickly. The latest MPlus is pretty fast at estimating. We've also specified 500 initial starts and 100 secondary starts, but we could easily double those numbers and estimate the models very quickly. So now the enumeration has all 6 models have been estimated, and I can see here you always need to check your models to make sure that they estimated, among other things, and look for errors. So we can see here, it looks like the model estimated. There's this warning. Some of the variable names were longer than 8 characters, but as long as those first 8 characters are different, we won't have any issues. You can see our sample size is correct. And we would usually want to look here to make sure the data, each of our 6 indicators, is reading in correctly. Everything looks good. We can see our class counts and some classification diagnostics. So I'm going to continue on. Next, we're going to generate a model fit summary table. And the first thing we need to do is read in our models into the R environment. So we can do this quickly by specifying the location of these files, which is MplusLCA. And we can see now we have this output LCA object, and it includes information from all 6 output files. And you can see here there's lots of different information that's been parsed out from each model, from each output file. So next we're going to take some of the summary fit information here and call it a new summary. So I'm going to run that. And then this syntax here is just going to calculate some additional fit information, such as IC criteria and Bayes factor and CMPK. These are all commonly used, like best recommended fit indices for evaluating model fit in LCA. So I'm going to calculate those, and we can see our object here is already starting to look like a table. And now this next syntax, we're using the GT package, and we're going to create a nice looking table. This first syntax here would create a pretty nice table, and then the rest is just fine-tuning the formatting so that it's closer to publication ready. And so this could all be adapted for your specific research context. So I'm going to run this, and now we can view this table. It looks pretty good, and we can see here that for this example, the three-class solution, um, the fit indices have agreement on choosing the three-class solution. The ICs bottom out on the three-class solution, and the BLRT, BLMR, phase factor, and CMPK all choose this three-class solution. This is fairly unusual, and in most cases, you will not expect to see agreement across all these indicators, but this is sort of an ideal research result. Close this. So now here we can make a plot to show the information criteria and quickly see how the IC, the fit indices bottom out at this three-class solution. So this is just showing the same information in another way, some of the same information. We see this nice elbow which bottoms out at the three-class solution. And if we like, we can save this figure in the figures subfolder and call it fit criteria plot. And then that will be saved in our figures subfolder. Next, we can compare conditional item probability plots. If we didn't get a clear solution, we then will need to use our theory and substantive considerations to choose between potentially like the K-1 and K+1 classes. So we might, compare the two-class solution, the three-class solution, and the four-class solution to look for correspondence with our theory. And this is just a nice way of quickly looking at those plots. And then finally, we will need to create a plot of the final conditional item probability plot that we would include in a publication. And so this needs some extra formatting. We can include information about the indicator labels as well as class counts and other information in this plot. And so we've created this plot LCA function that requires like 7 inputs, which you can see here and read about. So we're just going to read in this class 3 solution. So that's again from the MPlus LCA folder. And that this model is called C3 LCA, I believe. So now we've read that in model C3. And now we need to load in our plot LCA function, which we've written here. This first part just gets the data in the right format for plotting, and then we use ggplot to plot to create this plot. And now in the plot LCA function, we need to type in models C3 and include the number of items, which is 6, and the class number, which is 3. The rest I have already populated in here because it takes some time to type it, all the item labels. And so we can run this plot. And now we have a pretty nice looking plot. We could fairly easily make this plot black and white if that's what a specific journal requires, but this is already starting to look pretty good. And then we can save the plot in our figures folder and um, call it C3 LCA plot. We can save it. So this analysis would not be possible, of course, without the MplusAutomation package made by Michael Hawklist and Joshua Wiley, as well as Mplus, which estimates the models, and the supporters of R and the tidyverse, as well as the data source, which is uh, produced by the Office of Education. Thank you, and please follow along as new videos come out in our series.